Okay. So hi. So the agenda is that to get to know a little bit. This is more of an introduction, but at the same time to get comfort with with HANA database at a developer level, like the way we are familiar with other databases, right? Okay. So HANA, the primary things what they think is or claim is difference is that they claim it to be column storage, meaning a single column. If you have a table, then if the table has say 5 columns, then the data of one particular column, say suppose if we have a table called employee and has first name, okay, that first name column of all the people will be stored together. Okay, so if you want to run some query or anything on top of it, it is very easy. Okay, and there is some implicit encryptions as well. Sorry, not compression, not encryption. So there is a compression also that takes place. Okay, so that is what they claim as a one of the key thing. And the OLTP, and there is another term. Just give me a moment. Um, Usually you have for transactional databases, uh, we have what we call is the OLTP, right? So you have a primary transactional database, and then there is a warehouse database where you actually aggregate data for reporting and overall summaries, right? For aggregating, there are various models on it. Okay. I remember that for warehouse using like star model for schema design where you have facts and dimensions or something like that. So uh, what SAP claims is that those you don't need to have two different type of databases. Okay, you can just deal with everything as a single database. Okay, because of the way it is stored. Okay, because of the way data is stored, you get a lot of benefits out of the box with the database. Okay, and the other thing is that in memory. Okay, meaning uh, this actually like the I would say, let me put a bullet points here. Okay, this is one, and then when I go to this one in memory. Processing. Okay, so most of the data actually, like in HANA, everything comes into the in main memory. Okay, or most of it. It won't be like you hit a query and I go to the disk and fetch it. Okay, why? Okay, is that primarily this is because of continuous, the cheaper availability of the hardware. Okay, so that if RAM once upon a time was very very expensive, memory was very very expensive, right? I I remember like we used to struggle with multiple floppy disks just to download something from internet, say 2 3 images for a project, some demo. I want to put some nice images there, and and then something goes wrong, everything used to be bad, and then came this era of around same time there was this CD, right? Compact disc, and then the DVD, and then the DVD dual side or something like this. And then there is more, then later on this came with this, pen drives, the USB based memory disk, and then that killed everything else. And then even DVD-ROM is like is very rare to find in any computer now. The last few years, right? So hardware used to be very expensive, and now in terms of servers, mostly it is CPUs and the memory. Those are the two criteria, right? And both of them, most of the like what HANA guys, they claim that the traditional other databases are built when hardware was very expensive. Okay, they needed to optimize every bit of it. right? So, but now that, with the hardware being very cheap, now look at, what else we can do. Like, will that existing approach to build software is that right thing to do, or can we do anything better? And that's what they claim to be, like in-memory and column-based storage um, together is going to be bringing a bigger advantage. Okay, and then there is something called, the way how it is done is also is that, insert only. Okay, insert only means, like, you every update goes like an insert. Okay, every update goes as an insert. Okay, so meaning this one actually is very very interesting topic. Okay,
Hari
so
here column based means if we have same column name in multiple tables, how it will.
no, it's not about the column based. Isn't, don't worry about the name itself. Okay, for this particular table, when you define something, then it will have some identifiers. Okay,
Okay.
it will have a different way of managing, and from a practical perspective, you don't really need to worry, in the beginning. Okay, because it is going to be very much same. I'm going to show you how it looks like. Is not different at all. Little bit of unlearning from a graph database perspective, because we have been working with the graph database, and the way you write queries is little tuned to graph, and maybe we don't use the star when you say select, right? Select from will work, but here you have to give the column names or select star. Okay, and it goes with the standard SQL actually. Okay, right?
Okay.
So when I have to talk about the insert only, right? So there is something called delta storage, and then there is something called delta merge. So an update is actually done as an insert and inactivating a old current record. Okay, so what happens is internally or implicitly all the data is compressed. Okay, they apply some compression mechanisms. Okay, so that it is easy to fetch you, like, when you are trying to over the names or something, you can use a dictionary based or whatever, they use their compression mechanisms. Okay, they may not be same as the way you do ggip or something like this. It could be even simpler things. Okay, still you may be able to achieve a lot of benefit, like, uh, so assuming that is more internal. Okay, so when you do the compression and all that, your insertions may actually have bigger impact. So how do we deal with that? So what they do is that, when I have to insert update something. Okay, update is dealt in two steps. So delta storage and delta merge. Delta storage means that, they store this into some particular place, in the memory. Okay, again RAM, and uh, without any compression. Okay, so when if you do select star from or something like this, when you run a query, it will get from the, that whatever data from the actual database table, plus it will apply this delta storage to it, right? Something like this, and then this is the first step. But then, after that, at some intervals or whatever, at some scheduled times, or like, it may be doing and whatever based on the system resources, this delta is merged into the actual db, means where it is actually compressed, and everywhere proper logging is maintained. Okay, so that's how it is actually is going to so the delta merge, it actually put this into the main storage. Okay, so there is a main storage, and whenever there is a create, it is going to put that into delta storage. Delta storage, assume this is a temporary additional data storage. Okay, and write will write into that way, but read will pull from main storage and delta storage if it is applicable, right? And then subsequently all your delta storage will be merged into main storage. Okay, that's something slightly, from an architectural perspective, those are the interesting things that you can actually think of. Okay, and then you will hear that, SAP HANA is not just a database. It is also an application server. Okay, that's what they claim. I do not have much of an idea about how does this HANA as an application server works. They have something called HANA Access, or extended application services, or advanced model. HANA XSA. Okay, those are the two things that they have. But they claim that this is a server as well. Okay, from our current context, my idea is that I'm not going to dwell too deep into that particular part of it. Okay, and then um, it can be used uh, for storing geodata, and they do claim that a lot of search and text analysis can be done. There is a graph processing they claim, but the features are very very minimal within, like, where you can find shortest distance and width and something like that. you know and from an analytics perspective, they do have uh, you know better, because of the way data is stored, it becomes easy. Okay, and they do provide predictive analytics platform. They call it as a PAL. Okay, right. And then um, so those are the some of the things that this has, and then I'll not go too deep into it. Okay, so with this little bit of introduction, let us actually jump into how we can actually uh, learn HANA database. Okay, first thing for anything is that you need to have something installed, right? You need to have something installed in your computer so that you can actually make some progress, right? So I can actually show. So HANA Express Edition is available. Okay, I can actually, let me pull the download link and also paste it here. You can actually Google for SAP HANA Express Edition. Okay, so just Google for that, and then you will get it. Okay, so that link looks like this. Okay, so this is how you can actually download. And then they claim that you need to have 32 GB of RAM, but it still works with 16 GB. That most of our computers are 16 GB. Okay, it says required 16 GB of RAM. That's fine. It works. So we can download, and download actually is, it comes as a uh, uh, the virtual image. We can actually then download, okay, virtual box, Oracle virtual box, and then load that particular image. Okay, and then also I can share one more link where how to use it, or like once you have it, there is some standard steps that we may need to follow. Okay, so those, that also I can give a link. Okay, right. So let's look at the link. I'll share this information anyway. Okay, so wherein that by default there is a that virtual box. When you download and install this one, what, something like this. This is what the virtual box console, right? And where it will actually show IP address and you can log into it. But you don't need to really log into the virtual box image. As long as it is up, probably. And in the beginning you need to reset some password and all that. Okay, so but after that you can actually do an SSH, and I was able to connect. Okay, and actually wanted to show that this virtual box, that actually runs with Linux and the HANA database installed in it. Okay, so you don't need to do anything extra there, right? This is very very important step if you want to execute queries. Okay, right? This is very very important. Okay, and then the database client is actually dbeaver. Okay, so you can download dbeaver, okay, as a database client. I think there are other database clients, but dbeaver is one of the popularly, or like very important client that everyone uses. Okay, so this one is actually based on Eclipse. Okay, this one is based on Eclipse, so it's very I think we will get used to it in no time. There will be some tricky parts, but you know it all will be simple, right? So let me also put that link here. Okay, now having that, so if you have something there, now if you worked with Oracle and something like that, select chart from tab will give you all the tables. Okay, right? There's some meta queries. Okay, so I would just wanted to provide some of such queries, and let's see, select star from schemas. In case of Mac, you can pretty much press control and enter, and it will show you the results. Okay, so this databases, by default, I did not do anything here. Okay, I'm not sure if this is something created by the this, but when they prepared this HANA uh, OVA file, the virtual box image, they created this. But I think that these are the system level databases. This is nothing to do when you have HANA. Maybe they will have all these databases. Right? And the main one that we may be referring to is system. Okay, and you may connect to system and then create a schema and all that. Okay, and then uh, yeah, you can I am not sure about other these databases is this one, SAP REST API access. These are maybe related to the application server. I think they should be related to the application server, HANA being an application server. Okay, right? And then I can create, this office is mine, I created it. Okay, so we're going to explore that more. Okay, and then if you do select star from columns, okay, it is going to give you all the columns available in the system. Okay, right? There may be many other such meta queries. Okay, and then I want to get only the tables available in a particular schema, not everything in the universe, but just my schema. There's nothing here right now, we will be creating. Okay, and then select star from m underscore cs underscore tables. What it does, honestly, I don't know, but it does do, it is giving another list for me, and then this may be same as select start from maybe tables. Similarly, I do have the columns ms m underscore cs underscore columns. Maybe I have executed this earlier, but that's how it looks like. And then if you want to look at the procedures available, okay, the procedures. Okay, and I can get the procedures list, and then that there's a schema name, you can put filter name in the schema. Okay, so I can write where schema name equal to say office, right? So here I'm actually now going to see if there are any procedures in my own schema. Okay, similarly for functions also there is some difference. What is a procedure and function? It's very, for all the databases, procedure can take multiple inputs, multiple outputs. Okay, function usually is supposed to return single values. Okay, it cannot do too much of it, and function, well, and mostly we use it as a scalar. Okay, scalar function is a function which returns single value. Okay, it can return multiple values like records kind of thing, so but yeah, scalar functions are typically used, they're very common. Now they do have a dummy table. Okay, in Oracle it is called a dual. Okay, select start from dual. It's like, because from and you have to give a table name, that's mandatory there, right? So it's kind of similar with HANA. Okay, select start from dummy. Okay, or select something from dummy. I want to add some numbers, so I just want to add some numbers. Okay, sorry, select 2 plus 3 as total. Okay, so maybe let me do this. It says um, as maybe let me use this double quotes. Yeah, I think I have seen problems with this quotes. Okay. Yeah, see, somehow for the column names it did not accept single quotes. Okay, so you have to do double quotes or maybe do some escape characters. But but key idea here is that dummy. Okay, dummy. Okay, select from dummy. You want to do any other things. You want to call some simple function. I want to convert the particular date. Um, into some other format. Okay, or just get two dates. I think there's some utility functions, and there are a lot of utility functions available. Okay, with date or string, that so many other things. I'm not going to dwell deep into it, right? But I want to say that how you can actually call. You can use dummy when you don't have any table, but you want to do something, right? And then otherwise, if you see it so far, it is just the typical SQL. There's not much of a difference, honestly. Okay, the slight differences are there, but slowly we will get used to them, right? So let me actually drop the schema. Okay, okay, schema is dropped, and let me create the schema again, right? So it does take some time, yeah, it finished actually. So now I have very simple model. Sorry. I have very simple model. Say I have something called an employee. Okay, and employee has address. Okay, and very simple. Okay, I always try to use very simple structure. Okay, so um, okay, so let's say um, you know, but for the table usually we need to have what is that? Primary key. Okay, right? Primary key. And primary keys are addressed as sequences typically in all relational databases. Okay, in all relational databases. Okay, so let me do this. So the structure actually looks very similar, right? Create sequence. You need to, I think, when you are connected to a specific schema, maybe you don't need to really use the schema prefix, but it is safer so that it always, that, where it is going. The schema dot, I'm writing, address underscore SAQ, like just to say that is a sequence related with address. Okay. Starts with 1, increment by 1, right? And then how do I really use it, right? See here, I say that uh, Office.ADDRESS underscore sequential or SQ, whatever is the name of the sequence. Okay, dot next val, dot next val, and that's how when you are inserting you have to use this, and like and the value gets in there. Simple. Okay, so and then let me create a table. Look at this difference for the schema. I mean, particularly table, right? Create column table Office.ADDRESS. Okay, and the difference is that create column table. I'm not sure if there is another option available, but this actually says that the column storage. Basically it just means, I think, it's the column storage. Okay, so and then ID, bigint, not null, address line, nvarchar, nvarchar we use it typically when you have to use not just English but any other language text, right? When you use varchar and some of the like UTF, so you can support other languages. So if you want to use that, you can use nvarchar. But the meaning of this is always same. The varchar is same in Oracle or any other. I think in an SQL server like MySQL and other databases. This is common, from the Azure, the SQL standards, right? And then I want to create a primary key. So you can write your columns and their data type. You can see that, how am I doing it, right? The column name followed by the type name, database type. And then in case if it is supposed to be a size limit, then you specify that as well. Okay, this is very, very standard way. And once you do the column names, then apply your constraints. It could be more. Okay, it could be more than one. Okay, so constraint, and you give the name of the constraint and primary key and primary key. But you know what is, what is a column? ID, right? ID column. So that's how I want to define that. Okay, and if you have more constraints, you can actually put comma and then go on, right? So remember, the most of these databases, or all the databases that we know, are the constraints are like, the names are unique at the database level. This is nothing specific to this particular table. If you have address underscore primary underscore key as a constraint name and use it in as a constraint for the employee table, then it does not make any difference. You won't be able to create again. Okay, if you, I mean, just by the name of it, it does not like make anything different. Okay, it just try to be unique name. Okay, and the way how we tend to use is that always try to give the table name and then some context of it as a constraint. And this is nothing to do with HANA. Okay, it's general design practice, that how you develop, right? So now that I created earlier script, now I'm creating the table. Okay, let's try to run this particular query here, tables, and let's actually run. Come on, I was supposed to get this one. Seriously, I did not see this, huh? So create table, column table. Okay, see, it exists, but I did not fetch it immediately. So I need to see why it did not show up. It is supposed to actually show up.
Hari, you didn't insert the record, right? You just created a table.
I know, but I just wanted, this is about the select start from the tables. It's a metadata. It's about the table
Okay.
names. Okay, it's supposed to be like table names, but
Oh, like
maybe
this
that
because
yeah. It's not the data I'm querying. Okay, okay.
Maybe we need to commit, I think.
hmm No, this is like DDL, right? Now, why do you think that we need
Yeah, create
DDL?
DDL.
Yeah,
Yeah.
create is always DDL. For the this one, I can insert. Okay, and I can insert. Okay, there is another address I can insert. Okay, I'm able to insert. Okay, let's see how it goes. Okay, and then I want to create another table called employee table. Okay, and this is a sequence for employee. Okay, what I'm doing is, so if you see that this particular guy starts with 100. Hold on. What did it happen? Okay, I think it was executed already. So, and it starts with 100 just to have something different. Okay, and nothing specific. And then I have very simple table structure: employee and ID, first name, last name, address ID, title, manager ID. Okay, now employee's manager is also an employee, right? So that is the reason manager ID. Right, I don't want to complicate it right now. Okay, I want to include some calculations and salaries and bonuses or something like this, but subsequently. So here, foreign key, look at this, right? I'm adding foreign key. Okay, now address ID, the column here, references the schema name, office.address, and then what is the column? ID. So it is referring to that particular column. Okay, now manager ID. Okay, manager ID is a foreign key that references office schema of employee table and the column ID. Okay, right, because manager is an employee. And then create a constraint, primary key constraint, right? So this is going to be my employee table. Wonderful, right? Now, okay, so let's see how the insertion, if you see, right, um, insertions are simple. Like only thing is that, how we generate with, the sequence values. Okay. And then you need to give, the address ID value. Okay. So let's try to give something like 100 here. Okay. So it does say only, okay, see here. Okay. Foreign key constraint violation, column update failed on employee with, only found 0 of 1 rows from, employee address ID. Basically, it says that, that foreign key does not exist, right?
Yeah.
So we can execute this, right? And then I want to do a very similar thing. Now let's create another guy, say John Doe, and his boss is going to be Daniel. Okay. See here, why am I using 101 is because this guy starts with 100. Okay. So yeah, I'm able to insert that now. Okay. Now select start from employee. Okay. You see, I have my data here. Okay. Let's go back. I still don't see it. I think something went wrong. Okay. Okay.
It's their office under this particular thing. Where, Hari?
It is actually here.
Schema
Okay.
capital letter level, sir. Sorry.
That's
Case sensitive, maybe.
Case.
it's not supposed to be. Okay, yeah, it is. That's interesting. I was not expecting it to be case sensitive. Or maybe, let me just see. It may be to do with the double quotes or single quote. Invalid column name. This. So this guy uses, double quotes for the selection, projection, and for filters, single quotes. Okay, wonderful. Okay, that's. But you see that information, right? So I'm able to create tables and yeah, and insert data into it, and there's not much of a difficulty for us. It is pretty much, typical relational databases. Okay, so that's little bit brief introduction, right? And then let us see, if I can actually write some procedures. Okay, so I was actually trying to create something. I'm not going to use this one right now, but let me see here. So procedures or the business logic, or whatever logic you want to do with SQL. One of the limitation is that each statement is independent. Okay, I cannot build a story including multiple SQL statements. Each statement is individual, and there is no way you can transfer data from one to the other and all that, but you can do all the logic. Typically how we do it, we prefer to do that everything in the application programming, right? And sometimes, or for the benefit of performance, if you have to execute some, say, 5 queries one after the other, based on some data, and 5 queries, but maybe you are dealing with, say you get a employee, and then you try to get his title, or like, from another table or something like this, and then for each employee you are going to do another query. Okay, so when you do that, every time there is a network call going. Okay, and based on the, and you are doing a processing in the application server. When we do that, sometimes, or like, if the based on the data size, it could cause performance impact. It could cause performance impact. Okay, so procedures help you to execute everything at the database side. There is no network calls here, there is only single call. Okay, hey, execute me this. Okay, and then you can build your complex logic into that database, in the procedures or functions, and execute whatever you want to do. Okay, and one such example is right here. Okay, hold on. Yep, I know. Begin and let me actually comment that particular exception handling part for now. And this guy is still says yeah. Okay, yeah. Sometimes those errors are stupid, right? uh, it needs some smartness. I don't see much of a difference between other databases when with HANA how we see the errors. And if there's a problem at the end of end, and it says it's before the select or at select, and sometimes for the weak hearted, you will go in the all wrong direction. Okay, so this is how you write procedure. Okay, so the syntax is that create, or it's not mandatory that you have to use replace thing. Okay, create procedure. If you only use create procedure, and if the procedure exists already, it will fail. But create or replace will make sure that every time you execute it, it actually replaces. If there is again, okay, right? And the procedure name. So procedure name. Then you can write the in and out. There can be any number of input parameters, there can be any number of output parameters. Okay, there can be any number of output parameters. Do comma 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 comma. Okay, so first one here, there is only single parameter, right? In, that's the direction is input, right? If it is an output thing, you say out. Okay, so in, and then what is that field name or for this procedure, what is this input field name, and that is id, and what is the type of it, int. Okay, and then I don't have any other parameters, so you close your parenthesis here, right, for the parameters, and then say as begin. So meaning, as, and then look at this body, right? That is the one, okay, as begin. Okay, and then you do the declarations for if you want to have any variables. If you want to have any variables, you can declare variables of all the types and more, and that is one thing you can do. And then exception handling, for different conditions, you can do error handling, and this one I was trying to actually grab the exception and insert into an error message table. Okay, and it did not work because I'm doing something wrong here. The way how I have to capture, that is a meta information already, that SQL error code and SQL error message, they are supposed to be a standard, available things. Okay, when something error happens, you will have those values giving the recent error information. Okay, I wanted to grab that, and but this way of dealing is wrong. Okay, so I'll pass for now. Okay, I'll pass on that. Okay, but this how you do. And then see if how to do, right? Declare exit handler for SQL exception, begin, end. So everything will have a begin and end. It is like your curly brackets, the parentheses that you have in Java code, right? That way we just assume that it is that, begin and end. This is a standard SQL structure. Now what I really wanted to do is that show that how to write a procedure, and I'm just going to do what, select first name pipe, I'm appending this. Okay, and then there is an empty space, and then last name. Look at this, last name plus first name plus last name, as name I want to return that as a single value. Okay, from Office.EMPLOYEE, where id equal to see here colon and id, that is the input parameter. This is how you will be referring to the input parameters. If I'm referring to the arguments, then this is what you say when you say colon. Suppose in case like this, right, this query will still work fine. Okay, right? And how do I call? Okay, I can call like, call, right? Call, get name. You see here, it works, right? So then there was another simple thing that I tried to explain. Okay, and I'll stop with this. Okay, so that we will have enough time to digest. So I just want to do something where I do slightly different. Okay, I say that if my title is manager, okay, give the salary as something. Okay, and if it is developer, give something. There's a fixed component or maybe bonus component or whatever. At different amounts. And how? I mean, so this is going to be very similar. Okay, but there's slightly different way of how I'm structuring the data, and you need to pay attention to this. Okay. Okay, so create or replace procedure, decide salaries. Okay, out. Okay, this is out parameter. And what is the parameter name? EMP underscore salary. See, EMP underscore salary is what? Is the out parameter name. Okay, and then what is the type of the data? It is a complex data type. Say that okay, yeah, it's kind of a table with you do the table regular thing. ID of integer type, name of envarchar 200, comma, salary integer. Okay, that's what I'm trying to do. Right? So emp underscore salary is not a single type. It's not an integer. It's not a string. It is of type table. Why did I choose this one here? I wanted to introduce, now typical things, you will figure out how to do it, right? But then there are ways, there are different other type of, complex things you can do. Okay. And sometimes you can actually refer to an existing table. You can write that particular table itself here or something like that, but this one, it stands out slightly differently, right? I want to return some data, I want to execute some business logic and respond with some data. Okay, and it's complex thing, right? Name and his uh, salary. Basically, there are only two things, ID, name, and salary. It can be complex than this. Okay, so I commented out that that SQL particular part because I was actually like not able to make the query work, and I did not spend time later on. Okay, now let us look at this the query, right? EMP salary equal to select ID as ID, comma, and you see here the pipe that works like a plus, right? So this one we have seen it already. Okay, that's the name. The interesting part is that case title. Okay, this is the switch condition. Okay, and you can write lot of things with the switch conditions. Okay, case title. Okay, means like okay, I'm building a switch condition for title. Okay, when the value is manager, then 5,000. When the value is developer, then 2,500. Okay, end means I'm ending the case. Okay, from this one. Okay, and in the case as salary. Okay, meaning that I'm actually exposing within the like selection itself, the projection. This is like all the values, projected values from the table. I'm actually doing some logic here. Just wanted to show, uh, and then what am I doing here? EMP underscore salary. I'm putting that into the output variable. Okay, here I'm assigning a value. Okay, as a result of a select query. Okay, and what is EMP underscore salary? It is a table type. Okay, so now if I execute this, yeah, it went fine. Okay, and then how do I call? If I have to call, and I don't like if you are sending some values, input values, you have to send. We have seen it in the top, the get name, right? In this case, it's output variable, and I just pass question mark. I think you can actually pass references to the Java objects or something like that. But yeah, but if you have to do from here, this is how you have to do. So look at it, right? So 101 Daniel Craig is 5,000 and John Doe is the 102 and his salary is 2,500. Okay, assuming it's dollars. Okay, so I think that's what I wanted to say. There is actually like there are database level triggers. Okay, where you can when you are this queries actually they don't work yet in the bottom one. Okay, so but you can actually build triggers. Triggers are typically used, when something is getting inserted or deleted or updated, and you want to mandatorily check something. Okay, that if you are creating an employee, then maybe you want to do something on that. Insert into some payroll system or some other a number of tables, some of the data to be created or something like this. You can do automatically by building a trigger. Okay, if it is an insert, you will have just the new row. If it is an update, then you'll have old row and new row. Okay, then you can compare. Oh yeah, this value means so old row means actually like database will give you a row with old data without this update modification, right? So then you can actually compare those values and build some logic, and it triggers can be a like complex things. And these are like the steps that are mentioned here in terms of procedures, okay, and as well as triggers thing is like please treat it like as a hello world example. Okay, and then I have seen like people writing like thousands of lines and all that, so complex, they make it so complex, and it's always a debate, oh, should you have business logic in the database or in your application? Okay, it's always and then um, this is things like some certain things like suddenly the barriers they break, and what is correct, what is not is tricky thing, you know and sometimes some people may say, yeah, separate your data from your logic, build everything into your application so that your data will remain independent, and the moment you start building a lot of procedures into database and start using and procedures help you to exploit the database features, and as you exploit, you start building the database dependency. Okay, and tomorrow you want to move to a different database, say SQL server. You know what, most of this may not be working there. SQL server may not honor this. It may have different type of programming there, different type of constructs, and then you need to learn that and see, oh, map this one to that and all that, it may become tricky thing. But if you write into one programming language, say if you build this into say Java or something like that, and then you want to change your database from HANA to SQL Server, you don't need to rebuild your logic. Just make sure that schema is ported correctly and then data is migrated, right? And it's always a debate. But the idea is that to have a glimpse of just a taste of it, how to do it, right? I think I'll give this information. I think I might have given this already, but this is really what I wanted to present it in terms of how I wanted to do it. Okay.